Next, I'm going to show you how to convert from radical notation to fractional exponents. Now, before we can do this, first thing I need to tell you is that a square root has a radical like this that has an index value of 2. We don't usually write the 2. We only usually write the index value if it's a number other than 2. But if you don't see a number, then you can assume it's a 2. And the way you can write this square root as an exponent is simply z raised to the 1/2 power. Anything, the square root of anything is the same as that thing raised to the 1/2 power. So z to the 1/2 power here, the fifth root, the index value is 5, the fifth root of h is simply h to the 1/5 power. Those two things are one and the same. So if we want to do something like z to the 4th, the 9th root of z to the 4th, well, that's a fractional exponent as well, where the bottom of the fraction is a 9. If you come back up here, you see that that was z to the 1/2. Well, that was z to the 1st power. So to write this as a fractional exponent, this is z to the 4/9 power. See, the top of the fraction, the numerator, comes from the exponent on the variable, and the bottom of the fraction in the exponent, the denominator, comes from the index value. So over here, this is going to equal h to the 6/3, which of course if you reduce that fraction, that's h to the 2nd power. But you can do it with things other than just variables. You could do it with numbers as well. So if I have the 4th root of 5, that's simply 5 raised to the 1/4 power. Or if I have 41, the 7th root of 41, that's 41 raised to the 1/7 power. So all we're doing here is converting from radical form to fractional exponent form. All right, so the hardest ones you're going to see aren't really that hard at all. Something like the square root, remember that's a 2 in there. It's a fractional exponent of a 2, of 1/2, sorry. The square root of z to the 4th, h to the 7th. Well, let's start by writing that as a fractional exponent. So I'm going to put everything under the square root in parentheses here. So that's z to the 4th, h to the 7th. And since the square root is surrounding both of these terms, that means the whole thing is raised to the 1/2 power. So I just took everything underneath the square root, and I changed it to raised to the 1/2 power because that's the same thing as taking the square root. Now, if you remember your rules from exponents, we can distribute that 1/2 to both of these exponents by way of multiplication. So 4 times 1/2, half of 4 is just 2. So that's going to reduce to z squared, z to the 2nd power. And then 7 times 1/2, that's h to the 7/2, which is 3.5, but it's better to keep it as a fraction. But both are technically correct. 3.5, 7/2, same thing. This is as simplified as this gets in terms of a fractional exponent. So these two things are actually the same. Okay, last one. The square root of z squared times h to the 100th power. Remember that the index value of a square root is a 2, so I like to write in that 2 just in case. I don't want to forget. And I'm going to change that to z squared times h to the 100th power, all raised to the 1/2 power. I can simplify that a little bit more by distributing the 1/2 to both of the exponents by way of multiplication. So that's going to be z to the, well, 2 times 1/2. Half of 2 is just 1. So z to the 1st power times h. 100 times a half. Half of 100 is 50. So that's just z times h to the 50th power. That's the final answer. That's as reduced as it gets. Because we don't always write the exponent of 1. We usually don't write the exponent of 1. We usually just leave it off. It's not incorrect if you write z to the first power, but we usually leave it off.